Hello everybody, this is Geometry Chapter 5 Test Review, and I am going to be moving through my list of things that are reminders for the test, and I'm going to quickly move through the chapter with you. I do imagine that it will take more than one video, so please expect that. And the first thing that you need to think in terms of being very on top of is the theorems. Of course, you need to know the theorems backwards and forwards, including their converses, and you need to know how we mathematically apply them. The second thing you need to remember is about your note card that I gave you. That is the card that you need to use on the test, but how you get the material onto it is up to you. And let's see, the next thing that comes to mind for your test prep is the points of concurrency. You need to really study those. You need to really understand how they apply mathematically. For example, you need to know that the circumcenter is the point of concurrency or the point of intersection for the perpendicular bisectors of the sides of the triangle, and that the circumcenter is equidistant from all of the vertices. For the end center, you need to remember that it is made by the angle bisectors and that it is equidistant from the sides of the triangle. You need to remember that the centroid is created by the medians. A median runs from each vertex to the midpoint of the opposite side, and the centroid is the center of gravity for the triangle. It is also 2/3 of the distance from each vertex to its opposite side. And lastly, the orthocenter is the point of concurrency for the altitudes of the triangle. And the altitude is a line that runs from the vertex to the line containing the opposite side of the triangle. It can fall, this point of concurrency can fall inside the triangle, on the triangle, or outside the triangle. All right, so the other thing you need to know how to do very carefully is to apply all of these mathematically, but also to be able to look at a diagram and know which one it is that you are applying and therefore which characteristics you apply. For example, if you are, actually let me turn to, bear with me for just a second, let me turn to the page that would have circumcenter on it. I'm looking for a good example. Y'all bear with me for just a second. I don't see a perfect one of what I'm looking for, but if you were to get a diagram like this is on page 307, you would know that you were dealing with the circumcenter because you have perpendicular bisectors of each side of the triangle. You can tell that P to this BC line is perpendicular and it bisects because they show you that each half of that line segment BC is congruent to the other one. You can tell that P to AC is a perpendicular bisector for the same reason, and P to BA is a perpendicular bisector also for the same reason. That tells you that you're dealing with the circumcenter theorem. Now hold on, I'm going to flip the page. Let's look at another example. I'm looking for examples that really help you decide how and when you apply what. Okay, I'm still not finding a good example of that. So the other option is that a test question would give you that information. It would tell you that you're dealing with angle bisectors, like in this example 3 on page 309. Let me look at, sorry y'all, I did what I'm very prone to doing, drop the phone. Let me look for just a second for another one. Okay, here's a good example. So here is one that, this is on page 312, and this one shows you that you are dealing with perpendicular lines running from P to each side, and if they told you that AX was congruent to XC, it certainly doesn't look like it is, but if they told you that it was, then you would know that you are dealing with a perpendicular bisector. So what I mean by, excuse me, by all of this is you being able to glean that information from your diagram. Okay, let's move on to other parts of my list of things that we need to go through. Okay, the mid-segment theorem. Let me get to that page. The mid-segment theorem is on page 5-4. Let's look at that. The mid-segment of a triangle, and this is super important for you to remember, is going to run parallel to the base that's below it. Now we can draw that mid-segment in any orientation of this triangle because the triangle is going to have 3 mid-segments. The mid-segment runs from the midpoint of one side to the midpoint of another side and then runs parallel to the third side. So in this case, XY is running parallel to PR, XZ is running parallel to QR, and YZ is running parallel to PQ. We can tell, and this is one thing I'm talking about with gleaning the information from the diagram, we can partly tell that it's a mid-segment because we have QY congruent to YR, and PZ congruent to ZR, and PX congruent to XQ. So you can tell that it's hitting all those midpoints and equally dividing all of those sides. The thing that would really help you to know that this was a mid-segment, in addition to that, would be if there was a parallel sign right here and then right here, or on XZ and QR, or on the third set. Another thing that would help you know for sure that these lines were parallel and that it was in fact a mid-segment is if you had congruent angles created in there. For example, if PZX was 41 degrees and ZXY was 41 degrees, so that's this angle and this angle, those would be alternate interior angles, and therefore we would know by the converse of the alternate interior angles theorem that those two lines were parallel. Another way would be corresponding angles that were congruent or same side interior angles that were supplementary. Those are things that would allow you to know that those two lines were parallel. Look for that kind of information on your test. Remember, the test may not say these are mid-segments, or it may not say this is the orthocenter or this is the circumcenter. Those are things that you must be so familiar with the theorems that you are able to deduce from the information that they give you in a diagram. All right, so make sure that you go back and review, if you need to, the congruent angles or the same side interior angles, which are supplementary, that are created by parallel lines, so that you can accurately apply those in your test as well. All right, hold on and let me look at my list for a minute. Okay, let's see. Okay, there's a question on the test, and it's actually number 10, and I'll talk to you about it just a little bit before the test on Thursday. But it has to do with right triangles, and it says something like, which of these things is not possible for a right triangle? I don't remember the exact wording, but again, we'll look at it on Thursday. But you need to remember what the characteristics of a right triangle are. For example, the first most important thing is that you know that it's going to have one 90-degree angle. It doesn't have to be one angle in particular. It could be any of the 3 angles, but you know that there has to be a 90-degree angle. You know that it cannot be obtuse, because once you have a 90-degree angle, there are only 90 more degrees that are going to fit in that triangle that have to be divided by the 2 remaining angles. So there can't be any obtuse angles in a 90-degree triangle, therefore it cannot be an obtuse triangle. It could be an isosceles triangle, so you could have a 90-degree angle, and then your 2 remaining angles could be congruent because of it being isosceles, but it certainly doesn't have to be isosceles. So there are lots of different variations. When you see number 10 on the test, you need to think through those questions or the answer options independently as to which ones could be possible for a right triangle, and then choose the one that is not possible for a right triangle. Okay, let me look at my list. Okay, let's flip in our book. Give me just a minute to get to where we need to get to. Probably lesson 5-5 if y'all want to be turning it with me. Yeah. All right, so we're going to talk about the sides of triangles. Now, as you can see, this is lesson 5-5, and we skipped over a good bit of it. We did not do indirect proofs. So we skipped over example 1. We skipped over the whole first page, in fact. But then we go to the top of page 333, and we have the angle-side relationships in triangles. This is important. You are going to need this for your test. All right, so let's talk through it for a minute. I'm just going to read the theorem to you. If two sides of a triangle are not congruent, then the larger angle... Hold on, y'all. Let me process this for a minute. This isn't the theorem that I thought it was going to be. Okay, yeah, this is foundational to the one that I was thinking of. All right, what it says is that if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. Let's look at this. So they're using angles A and C as our examples, and they're saying that AB, side AB, is greater than side BC. Well, what that tells us is that therefore angle C also has to be greater than angle A. So your longer sides are opposite your larger angles. Your smaller sides or shorter sides are opposite your smaller angles. Building on that, your very longest side is opposite your very largest angle, and vice versa. Now this is leading up to the hinge theorem, and we'll get to that in just a few minutes. And the converse, basically, of that theorem is right here, not of the hinge theorem, but of the one I just read to you, that if two angles are not congruent, then the same is true as what we talked about before. Then the smaller angle is going to be opposite the shorter side. The larger angle is going to be opposite the longer side. So you might be asked to put the sides of a triangle in order from shortest to longest, or you might be asked to put the angles in order from smallest to largest. And you're going to do that based on the information that they give you. If they're asking you to put the angles in order, they're going to give you the sides. And you're going to find the shortest side, and that's going to be your smallest angle. And then you're going to find the medium side, and that's going to be your medium angle. And then you're going to find the longest side, and that's going to be your largest angle. And vice versa, if they're asking you for the sides to be put in order, then they're going to give you the angles, and you're going to have to put those sides in order. If they only gave you two angles, of course you would be able to figure out the third angle based on the triangle sum theorem. All right, moving along, give me just a minute. Okay, another thing that we need to talk about is this theorem. Of course, I don't really need to be going through all of these with you because it's your responsibility, as we talked about earlier, to make sure that you know all these theorems, but I do want to make sure that you know how to apply them. So the triangle inequality theorem says the sum of any two sides of a triangle is greater than the third side. That means that looking at this triangle, if we add up AB plus BC, it must be longer than AC. And if we add up BC plus AC, it must be longer than AB, and so forth. So we have to do the math on that. And if you're asked if three different measures are possible sides of a triangle, you simply make sure that it works that way. Let's look at this one. 3, 5, and 7. Could this make a triangle? Well, is 3 plus 5 greater than 7? Yes. Is 5 plus 7 greater than 3? Yes. Is 7 plus 3 greater than 5? Yes. So all of those could make a triangle. Let's look at, I'm looking to see if we still have time. Yes. Let's look at this one. These could not make a triangle because when I add the first two, 4 plus 6.5, that's only 10.5. That is not larger than the third side. Therefore, we could not make a triangle out of that. Okay, I need to end this video, so be ready for a second one.